All right, so in this video, we're going to go through sample question number 73 from the Society of Actuaries ExamP list of sample questions. The question reads, an actuary models the lifetime of a device using a random variable y, which is equal to 10x to the 0.8, where x is an exponential random variable with mean 1. Let f of y be the density function of y. We need to determine f of y for values y greater than 0, right? And then they give us a bunch of formulas. And we need to figure out just essentially what the density function of y is. So this is a classic problem in univariate transformations. I go into, univariate transformations and the strategy for approaching these problems in my video for question number 71. So if these give you trouble, take a look at that video. It's a good question to really get a handle on these kind of problems. But essentially, we have two random variables, x and y, and typically we're given the PDF or CDF for one, and we need to use it to get the PDF or CDF for another. All right, so let's say this is my stuff for x, CDF, and this is my stuff for y. There's the PDF, y also has a CDF, and y also has a PDF. What are we looking for? We are looking for this guy, right? What are we given? Well, because x, we're told that it's exponential, we should know the CDF and PDF, right? So what I'm going to do is I'm going to use the CDF of x to get the CDF of y. And then I'm going to differentiate the CDF of y to get the PDF of y, which is what the answer actually calls for, or what the question actually calls for. So now I'm looking for f of y, right, the CDF. Now this should be equal to the probability that some y is less than or equal to some specific value of little y. And the way a transformation is going to work is I know y is equal to 10x to the 0.8. So this will change to the probability of 10x to the 0.8 is less than y. And my goal is to isolate this random variable x. So probability, this is going to be just x to the 0.8. less than or equal to 1 over 10, right? This is just algebra. You should be familiar with this. And rather than writing this whole thing as like the 0.8th root, what I'm going to do is just kind of divide, because I see in my answer choices that all of my exponents are in decimal form and there are no roots. So that tips me off that it's probably going to be better for me in the long run to write it as follows. I got my old TI 30x, what I recommend you use, and this is going to be 1 divided by 0.8 and 1.25. So this is going to be 1 over 10 to the times y, and then all of that's raised to the 1.25. Okay, now I have my CDF of y in terms of x. Okay, I found something that I can work with for the CDF of y. Now here's something that you need to have memorized. What is the CDF for an exponential distribution? Well, that is 1 minus e raised to the negative x over theta, where theta is your actual mean, your expected value. So let's put this in. So 1 minus, so this is equal to, right? 1 minus e raised to the negative 1 over 10 y to the 1.25. And that's all over 1. I'm not going to write it there, but we're told that the mean is 1. All right, so I got a CDF for y. What does that do for us, right? What does that mean? Well, I can simply just differentiate, and I'm going to, this looks annoying, differentiate, oh god. Oh no, it's not that bad. Okay, I'm going to differentiate to get the PDF. So easily, derivative of 1 is just 0, that goes away. Here, I'm going to do a nice little chain rule, right? A little bit of Calc 1. And it's going to be the derivative of this stuff up here. And that looks like it's going to be let's see. I have to bring this down and then multiply by 1. So it's going to be 1.25 over 10 y to the 0.25 multiplied by, well, it's a negative, so that's why I'm canceling that out, by the way. Multiplied by, and then the same thing, e to the negative 1 over 10 y to the 1.25. And that should be the CDF, which lines up with, that lines up with answer choice E, right here. Okay, this 1 over 10 is clearly the 0.1 written there. All right, this wasn't at all a difficult problem. The trickiness came into like reading all this. This is not fun to read, but it wasn't a difficult problem, right? We have two random variables, x or y, and each of those have a CDF and a PDF. We identified what we're looking for, the PDF of y. How are we going to get it? Well, we need to use x to get there. Because we're told the type of distribution x is, we know how to get the CDF and PDF. I determined that it would be easier to use the CDF of x to get the CDF of y and differentiate. Another solution would have been to use the PDF of x and then convert, right? There's a formula for you to convert to get the PDF of y, which actually might not have worked in this particular question, but it would work with, like I mentioned, number 71. If you want more review on transformations, look at number 71, my video on it. Okay, so what's the takeaway? Transformations. Identify what you're given. Identify what you need to look for. Figure out the correct path to get there, right? I can draw these little connections here. Okay. Typically, you'll have to either go from a PDF to a PDF or a CDF to a PDF. If you have to go from PDF to PDF, I suggest using the formula, right? There's a memorized formula to convert this. If you have to go from a CDF to a PDF, I recommend doing a transformation, then integrating. Okay? If you have to go from a PDF to a CDF, other way around. Use a transformation, then differentiate. Other way around is integrate, transform. Well, that's pretty much it. Bit of a long-winded explanation at the end, admittedly. But if you still have any more questions, leave it down in the comments. I'll answer it to the best of my abilities. If this video helped you out, hit the like button, subscribe. That definitely helps me out. And if you want to see more questions like this, I got a playlist. Check it out. ExamP sample questions done out. But other than that, thanks for watching.